Assignment 22, Factoring Quadratics, is an assignment that has a lot of kind of complicated explanation, but then the actual procedure, the steps of what you're supposed to do, are pretty simple. Alright, so for this assignment I'd like to introduce a game, and I'm going to call it the tic-tac game. So this is a tic-tac, not a tic-tac-toe, just a tic-tac. So here's the tic-tac game. If I have 3 and 4 on the sides, then I have 12 and 7 on the top and bottom. 8 and 2 give me 16 and 10. And negative 3 and 5 give me negative 15 and positive 2. Alright, so what is the pattern? What is the rules of the tic-tac game? You can go ahead and pause for a second to think about it. And the rules are that the number on the top here, 12, is the product of 3 times 4, and then on the number on the bottom is the sum of 3 plus 4. I wrote 7 there. 3 plus 4 gives me 7, and 3 times 4 gives me 12. 8 times 2 gives me 16, and 8 plus 2 gives me 10, and negative 3 times 5 gives me negative 15, while negative 3 plus 5 does give me 2. Alright, so the rules of this game are that you take 2 numbers on the left and the right. The top is the product or multiplication of those 2 numbers, and the bottom is the sum or the add of those 2 numbers. Alright, so that's the tic-tac game. So let's start playing the game a little bit. If I give you 4 and 8, then what would the top and the bottom be? 4 times 8 is 32, and 4 plus 8 is 12. Alright, but let's play a little bit of fun with the tic-tac game. What if I gave you the top number and the bottom number instead, so that you had to figure out, let's do 8, you had to figure out what goes on the side. So what 2 numbers multiply to make 12 and they add to make 8? Well, those 2 numbers are 6 and 2. What about 12 and 7? So another 2 numbers that multiply to make 2, but this time they add to make 7. Well, it might be a good idea to start factoring 12. 12 could be 12 and 1 make 12, 2 and 6 make 12, and 3 and 4 make 12. And the one that we want here is 3 and 4. So 3 times 4 make 12, but 3 plus 4 makes 7. What if I gave you some different versions of that? So there's all kinds of ways you can play this game. Alright, so the game isn't all that simple. So what if I knew the left and the top? So I know the product and I know one of the numbers. Well, the other number that would make 18 would be 2. And then, so 9 times 2 is 18, and 9 plus 2 makes 11. All right, what if one of the numbers is 0? How do I make something add up to 0? Well, it must mean that these cancel exactly. So let's try negative 4 and positive 4. So those multiply to 16 and they add to make nothing. What if I wanted negative 7 instead of positive 7? So how do I use 3 and 4 again, 3 and 4, but I have to make them both negative because 2 negatives make a positive for the 12, but when I add negative 3 and negative 4, I do get negative 7. So there's all kinds of tricks that you can play with this. You have to be really good with adding and subtracting. All right, so let's write some general rules of the game. So if I want the number on the top, I'm going to make it a nice big number like 24. And I want those to add up to, let's have them add up to 14. Rules of the game. Step 1, write all the factors of the top number. Okay, or in other words, write all the ways that I can multiply to make 24. So I'm going to do that here. 24 is 1 times 24, 2 times 12, 3 times 8, 4 times 6, and 5, 6. I think that does it. Yeah, I think that does it. All right, so I've written all the factors of the top number, and then step 2, figure out which pair of factors add up to the second number, the bottom number. All right, so those are the way. This is the way to play the tic-tac game. So all of the factors of 24. Incidentally, this is the reason why there's 24 hours in a day. When they were inventing the calendar, they picked a number that could be divided a whole bunch of different ways. So there's half of the day, and a third of the day, and a fourth of the day. So there's many different ways of factoring 24. The one of these that adds up to 14, this adds to 25. this adds to 14, this adds to 11, this adds to 10. So the one of these that works is 2 times 12. So 2 times 12 is 24, and 2 plus 12 is 14. All right, so first we're going to factor it, write all the possible factors, and then we're going to figure out which pair of factors add up to make what we want. All right. Why does this matter to you? Well, I've drawn a box here to multiply two binomials, because that's what we've been doing. So here's what the tic-tac game is good for. Suppose if I was multiplying x plus some number a. Now I'm going to leave a as some sort of parameter, and then x plus b, and b again is a parameter. It could be any number. So it could be x plus 2, it could be x plus 3. So I'm going to put x plus a on top, and x plus b on the side, and then multiply inside. X times x is x to the second power. A times x is ax. B times x is bx, and a times b is a times b. And then if I write that out, let me add the like terms in the middle here. These two terms both have an x, so just like we've been doing, the two terms on the diagonal that are the same degree, a plus b, x is going to be the middle term. So let's look. I've got my first term, x to the second power. In general, I have a middle term, a plus b times x. So I add a and b in order to give me the middle term. And then the last term is in the box. It's the top a times the side b. So it's a times b gives me my final term. Okay, so let me try that again here. All right, so my final term was a times b. All right, and that's my trinomial. So my from two binomials, x plus a and x plus b, I'm going to get a trinomial where the middle term adds a plus b, and the final term is the product. Okay, so again, this is exactly like the tic-tac game. If this was the number a and this is the number b, then the product is a times b and the sum is a plus b. All right, so I'm going to be playing a game like the tic-tac game every time I'm trying to factor one trinomial into two binomials. All right, so like I said at the beginning, there's an awful lot of explanation for something that winds up being really easy. I am trying to find two numbers that multiply to give me this, 80, and add to give me this, 18. All right, what are the two numbers that multiply to give me 80 and add to 18? They are positive 10 and positive 8. Let's check. 10 times 8 is 80, and 10 plus 8 is 18. So these are my two numerical factors. X plus 10 gives me my first factor, and x plus 8 gives me my second factor. Let's check to see that that works. In other words, I want to check that these two are equal to each other, and I'm going to use the box method. So I'm going to put my factors on the outside, x and plus 10, x and plus 8, and then multiply to make the inside. X times x is x to the second, x times 10 is 10x, 8 times x is 8x, and 8 times 80 is 80. 8 times 10 is 80. And then I can add my two terms on the diagonal, 8 plus 10 to give me 18x. So my final answer, if I multiply x plus 10 times x plus 8, I would get the trinomial x squared plus 18x plus 80. And so I have just confirmed that x plus 10 on the top times x plus 8 on the side does give me x squared plus 18x plus 80, which is the trinomial I wanted. All right, just like in the last couple of assignments, hopefully as we get through these, let's just practice that makes it seem more familiar. So I'm going to multiply to get negative 36, and I'm going to add to make negative 5. So what two numbers will do that? Well, let's remember the rules of the game. Number one, write all the factors of the top number, all the ways to multiply to make the top number. And then number two, figure out which pair of factors would add up to make the bottom number that you want. All right, so let's do that with 36. The factors of 36, the two numbers that multiply to make 36 are 1 times 36, 2 times 18, 3 times 12, 4 times 9 and 6 times 6. All right, so one of these two numbers is going to have to be negative because one negative makes a negative. So it could be maybe this one is the negative one, or it could be just the opposite, that this one's positive and this one's negative. But let's figure out what I get for each pair of these. All right, so this factor, 36 and minus 1, now I suppose minus 1 was here and 36 was here. All right, so I'm going to try these out one at a time. I know that they multiply correctly to give me the negative 36, and I want to know, do they add correctly to give me the minus 5? And the answer, of course, is no. 36 and negative 1 make 35, not 5. 18 minus 2 makes 16. We're getting closer. 12 minus 3 is 9. 9 minus 4 is 5. And then 6 minus 6 is 0. So if they cancel completely, this is the one that I wanted. All right, I'm getting closer. So I know that the two factors that I want to use are this pair here, 4 and 9. And I just need to decide which one of those two is going to be negative. When I multiply them, they multiply to make negative 36, so one of them has to be negative, but I don't know which one. The negative in the 5 tells me which one needs to be negative. Because this is negative, the bigger of the two needs to be negative. All right, so the solution to this tic-tac is 4 times negative 9 is negative 36, and 4 plus negative 9 is negative 5. So let's write that as our factored expression, x plus 4, x minus 9. And let me erase my factors here so that I can test that out. If I did it correctly, then I'm going to multiply together and get x squared minus 5x minus 36. And it's bound to work because I know the structure of the equation. X and plus 4, x and minus 9. Okay, I multiply here 4 and minus 9 to make the negative 36 that I wanted right here. And I add these two numbers, negative 9 and positive 4, to make negative 5x to give me the middle term that I wanted right here. So my final answer, if I multiply x plus 4 times x minus 9, I get x squared minus 5x minus 36, which is the trinomial that I wanted. It's equal to x plus 4 times x minus 9. So this is the factored form, and I would call these the two factors, factor 1 and factor 2, of this trinomial. All right, I'm going to practice more of these in video 2.